All right, so the very first thing is announcements. I wanted to remind you guys that you do have a midterm coming up next week, and it will be open between March 16th at 2:35, and it will close at March 17th at 4:20 p.m. So you can take this during class with Steve, and if you do it that way, you would just attend the regular Zoom lecture, and during class, you will have your midterm. And the benefit of doing this is you can ask him questions if you're confused on like what the question is asking. And once you start it, you will have 70 minutes to complete it. Or if you don't want to take it in class or you can't make it at that time, you can take it on your own anytime within this window. Just when you start it, you do have to finish it. In Canvas, he created a practice test, and this practice test is to give you a sense of the type of questions which will be on the exam, not necessarily the coding concepts. So it will be like, is it going to be multiple choice? Is it going to be short answer? Are you going to have the right codes? That's what this practice test is for. So I recommend taking that, but it does not affect your grade, even though it's worth points. Next week or even tomorrow, we will start doing SI exam prep. And how that will work is I will make at least 2 practice tests. And these practice tests will have questions that will be covering stuff that you already know from the class. So it'll be like questions on for loops, on strings, on data types, while loops, all that stuff that you already know. And I'll just put a practice test together for that, and we will do that in SI. I was wondering, do you want to do that tomorrow, or do you want to continue on with strings tomorrow? Like we could do the 2 SI sessions next week could be all for practice test, or we could do 3 SI sessions with practice stuff for the test. What do you think would be better? Here, I'll pull up what I mean by practice testing for SI, if that would help you with that decision. So we will have like a practice exam. I might do it in either Google Forms or Canvas, we'll see. And what it would look like is we would just have a test like this. You guys would tell me the answers to the question in chat, and then we'd go over kind of what that means. So we'll have one like this where we do it as a group, and the other one I'll have you guys do it on your own. So what do you guys want to do? Tomorrow practice test or tomorrow regular SI stuff? Okay, we will look at practice test tomorrow. And we can also change this depending on how far along we get with the strings and stuff. Okay, so now into regular SI stuff, unless anyone has questions on the exam or midterm or anything at all. If you do, you guys know you are welcome to interrupt me or type it in chat whenever you want. Okay, so our first activity for today is to complete the FizzBuzz program that we started last week. Just to remind you guys a bit about what that is. This is a programming problem which they give to programmers applying for job applications, and they are told these instructions. So the instructions are, you write a short program that prints each number from 1 to 100. And then if the number is a multiple of 3, you print out fizz. And if the number is a multiple of 5, you print out buzz instead of the number. And if it's a multiple of both 3 and 5, you print out FizzBuzz. So over here, we have an example run of it. Of course, it's only going up to 15, but it gives you a sense of what the program should be doing. Last week, we started off by writing a for loop, and we said that we're going to start I at 1, which means that our numbers are going to start counting from 1. And then we say, well, I is less than or equal to a number, which means that we are going to continue looping until I is less than or equal to 100. And then every single loop, we are going to increment I by 1. So I will get my terminal open so we can run this and see what progress we made, how it looks. Okay, so here is what we have written so far. We have numbers counting from 1 all the way to 100. So we've completed part of the program. We have the counting to 100 each on a new line. Now we need to figure out what can we do to make it so that instead of printing 3, it prints out fizz. Instead of printing out 5, it prints out buzz. And instead of printing out 15 or multiples of 3 and 5, all these are the multiple things, it prints out the specified keywords. So what do you guys think we want to do here?
An if statement
Yeah, that sounds good. Where do you think we want it?
after the for loop.
After the for loop. So down here, like line 10.
I'm not too sure now.
It's okay. There's no wrong answers. We're going to try out some stuff. So we'll say if, and what condition are you thinking? Well, I definitely agree an if statement is what we need here. And the reason being, we have a program for which with different numbers, it's going to do different things. So we're going to need to make some decision-making statements here. And we know that those involve if statements. So a good place, a good thing to think about is where do we want this if statement to happen? So we know that the numbers that we're seeing on my terminal here are coming from this cout statement right here. And I want you guys to notice where that is. Well, it's inside of the for loop, which means that if we're going to try and change anything with this output here, we would probably want to do it inside the for loop because we know the output's coming from the for loop. So if we're going to modify what's getting outputted here, we're probably going to want to do it inside the for loop. So I'll take this if statement and stick it inside the for loop. Okay, so now we have an if statement and we got to figure out our condition. So we know that we are going to need at least 3 decision-making statements here because we have 3 different, actually 4 different conditions. Condition 1 is if it's a multiple of 3, we print fizz. Condition 2 is if it's a multiple of 5, we print buzz. If it's a multiple of both 3 and 5, we print fizz buzz. And our last condition is if everything else is false. If it is none of these, then we just print out the same number. What do you guys think that we should put in this if statement to determine one of these conditions? So we don't know which one we're going to determine first, and we also need to know what the condition is to determine that. Okay, I'll make this a little bit simpler. Which of these 4 conditions do you guys think that I want to check first?
The fizz.
Fizz. All right. So we know that we are going to want to output fizz if the number I, remember our number is coming from I, is a multiple of 3. So this is a little bit of a tricky one, but do you have any idea how we could check that?
If I is equal to 3, well,
if I equals 3, then inside of our statement, I guess we'll try printing out fizz. And we'll put an end line at the end. Okay, so now we're saying if I is equal to 3, we are going to cout fizz. And I think a good thing to put in here as well is an else statement. And the else, I think, should probably have this cout statement because if our number is a multiple of 3, all we want to do is print out fizz. In the example, we see that 3 is not printed, it's just fizz. So to achieve this, we're going to say if I is equal to 3, we're going to print out fizz. And otherwise, if it's not equal to 3, print out I. So now that we've made some progress, I think it's a good time to compile and run to make sure that what we're doing is actually on the right track. Okay, so we have 1, 2 fizz. And then 6 is still 6, 9 is still 9, 12 is still 12. So why do you think that is?
because we include the multiples of 3.
Yeah, there you go. So we could do a few things here. We could do it the long way or the quick way. So I'm going to show you guys the long way first, because this might be what you're thinking. We could say if I is equal to 3, or this is the or operator, I is equal to 6. And then or I is equal to 9. And I'll just stop there because that would be a lot of statements. We could do it this way. We could say if I is 3 or I is 6 or I is 9, then we'll print out fizz. So I'll compile and run that and prove that that does work. So we see fizz where 3 should be, fizz where 6 should be, and fizz where 9 should be. So we could do that. We could make a really, really long if condition for all multiples of 9 from 1 to 100. But that sounds like a lot of work, a lot of typing, and a really long conditional statement here. So I'm going to show you guys another way that we can do this. And before I say it, does anyone have any idea? And if not, that's totally fine. I will let you know because it's something we haven't talked about a lot.
No.
Okay, all good. So the thing that I want to remind you guys of is the modulo operator. So that is the operator that is a percent sign. And what it does is it finds the remainder between two numbers. So if we say A modulo B, what this is going to result in is the remainder of a division problem where A is divided by B. So if we had long division and I say 2 and 13, we know that 2 goes into 13 6 times, and we put a 12 here, but we have a remainder of 1. And this is what the modulo operator would give us. So if we said 2 modulo 13, we'd get this 1 value right here. But one thing to think about is if whatever number we put in here is a multiple of 2, we'd end up with a remainder of 0. And if not, we'd end up with a remainder of 1. And this is true for any number. So if we said 3 and we had a 10 here, well, 3 goes into 10 3 times, we end up with a 9, and we have a remainder of 1. So what this remainder tells us is that 10 is not a multiple of 3. So knowing that, if we end out with a 0 here, the number here, if we end up with a 0 here, the number here is a multiple of 3. And if not, then it's not a multiple of 3. So this is a shortcut that we can use to make this program a lot simpler. Let me delete everything that's on screen here. Okay, there we go. So we are going to use modulo. So I said that if I modulo some number is equal to 0, then I would have to be a multiple of this number that I have the dash under. So what number do we want to find out if I is a multiple of?
Wait, can you repeat the question again?
The question is, so when we have a statement, which is written out where's my pen? A modulo B is equal to 0. This is going to be true when A is a multiple of B. And the reason being, if we had a division problem right here, and we said this is going to be the B part, 10 divided by 3, this is the A part, and we solved this. So we said 9, 3, so 3 times 3, 9, and we're left with a remainder of 1. This is a remainder. So by this logic, we know that if there is a remainder, the number here, B, is not a multiple of the number A. And if it is 0, 9, 3, 0, we know that 9 is a multiple of 3. Does that make sense? We end up with a remainder 0.
Yeah.
Okay, cool. Awesome, I'm glad. So I want to know what number in this conditional equation should I see if I is a multiple of 20. Okay, let's give that a shot. So I'm going to, am I saving? I am saving this. Okay, so now I will compile and run the executable. So now we see we have fizz sporadically through our program. And let's see if we can make sense of why we're seeing this. So I have fizz at 20. I have fizz at 40, fizz at 60, fizz at 80, and fizz at 100. So what pattern do you notice?
All multiples of 20.
All multiples of 20, you nailed it. So if I were to put 12 here, we see fizz everywhere that we have a multiple of 12. We have 12, 24, 36, and so on all the way to 100. So our problem here is for every multiple of 3, we want to print fizz. So I think a good number to put here would be 3. So now we say every time we have a multiple of 3, we are going to output fizz. And we can verify that by running our program. There it is. So now we see 3 fizz, 6 fizz, 9 fizz, all the way up to 100. Every single one is accounted for. That was a lot cleaner of a solution, I think. Does that make sense to you guys? How that worked?
Yeah. Can I see the 30s? Like how I printed out the 30s?
If we switch this to 30,
Oh no, like once you got to the count 30. Okay, so it's fizz. Oh, okay. Cool.
all right, cool. So now of our list of things to do, we have crossed off for each multiple of 3, print fizz. All right, so I'm gonna have you guys tell me how to do the next one. How do I, for each multiple of 5, print buzz?
Can we add an or statement? Or
Right here?
yeah,
Or, and what do you think we want to put here?
I% 5 is equal to 0.
That sounds pretty good. Let's try it out. So if I compile and run this, we have 1, 2 printed out normal. And then we have fizz at 3, as we expect. Then 4 is printed out normally. And then 5, we have fizz. But we actually wanted to print it out here was buzz. So we are on the right track, that's for sure, because now when we have multiple 5, we're printing out something different. But we're printing out fizz because we say if this stuff is true, if it's a multiple 5, we'll print out fizz. So that's exactly what it's going to do. We want to change it so it prints out buzz if it's a multiple of 5. What can we do?
Maybe like an else statement, another one.
Okay, so like else if we have some sort of condition. Let's see, is that enough braces? It is. Okay, so else if, and I'll put your condition that you just said back in there. I modulo of 5 is equal to 0. This means that if this is true, I has to be a multiple of 5. Hey, Samantha. All right, so now we are just finishing up our FizzBuzz program. Let me know if you have any questions on what we're doing so far. Basically, what we did is when I is a multiple of 3, we printed out fizz, and now we're working on when I is a multiple of 5, what we're going to print. Okay, so when this is true, we will enter the if body. What do we want to do when I is a multiple of 5?
See how it buzz.
Perfect. And an end line, so stuff appears on the correct lines. And I will save and recompile. There it is, we're closer. So now, when we have 3, we print fizz, 5 is buzz, 6 is fizz, 9 is fizz, 10 is buzz. Okay, so we're getting really, really close here. The thing that I want you guys to notice is when we're at 15, so this fizz right here is 15. We are printing out fizz, where we actually want to print out FizzBuzz for multiples of both 3 and 5. So we have one last part to this. We just got to do the 3 and 5, and then we are all done. How do you think we could do that?
A while loop.
Okay, where would you put the while loop and what the conditions be?
I think still be inside the for loop.
Okay, so you're thinking like a nested loop?
No, we haven't even gone over that yet.
We haven't.
Never
You're ahead
mind.
of the game there. Well, I can give you a hint that it's not going to be a nested loop. But that's great you're thinking about those. And we are going to go over those next week or maybe even Wednesday. We'll see. I guess that would be tomorrow. I don't know when Steve's going to go over them, but very soon. Okay, so we know we haven't gone over nested loops yet. So that is not going to be the solution here. We want to know when I is a multiple of 3 and I is a multiple of 5, we're going to do something. So if we follow the same pattern that we've been doing using decision-making statements, we could say else if, and then we put a condition, and then when that condition is true, see out fizzbuzz. Okay, so now the condition, this is just an idea. Does anyone think this is going to work before I continue? What do you think about this idea?
Yeah, I think it should work.
Okay, so now we say else if, and thank you, James, forgot about that. Else if I modulo 3 is equal to 0. And then we have our handy little and operator here. So we say ampersand, ampersand, because it said it was a multiple of 3. So we check if it's a multiple of 3, and then we can use the and operator to put in another condition here. So if it's a multiple of 3 and I modulo 5, modulo 5 is equal to 0, then we should print fizzbuzz. So let's give this a shot. Okay, so running the program. Let's see. So this is the new one, but at 15, we are still getting fizz. So I want to talk to you guys about the flow of these if statements. And this is a very important point that when I first attempted this program, I did it exactly as you guys did. But there is a catch here. And the catch is, let's pretend that I is 3. No, I is 15 for our purposes. And when we go into our if statement, the first thing we're going to check is if I, which is 15, modulo 3 is 0. This is true. 15 is in fact a multiple of 3. So since this is true, it's going to come right here and it's going to see out fizz. And then since this if condition was true, the else stuff doesn't execute. We actually go from this curly brace all the way down here and exit. So since the first if was true, it's going to do that. And then it's going to exit the whole decision-making clause and continue on with its looping. So how do you think we can fix this? And I'm going to tell you guys it's 2 steps to fix it. We're going to keep the if statements. We just need to change the conditions. What do you guys think?
So the 0 equal to 1?
Right here?
No, on the last else if.
Okay. So let's see, 0. And you're taking this 0, 1, and this 0, 1. Okay. So let's save that and execute. So now we are getting some interesting output here. And the reason being I forgot an end line. Okay. Let's save that so we can actually look at the real output that we got. Okay, so we have fizzbuzz appearing at 1, fizzbuzz appearing at 16. So we are getting the fizzbuzz stuff to happen, but it's not happening at the right intervals. And the reason being, we say when I modulo 3 is 1. I'm going to just test it out with one of these values. So we say 1, 3. Oh, yes. So 3 times 0 would be 0. And then we're left with a remainder of 1. So when we have a remainder of 1 for 3 and 5 1. So 5 times 0 is 0. We have a remainder of 1. Both of these are true. And since it's saying when the remainder is 1, do this stuff, that's exactly what it did. So we still want remainder of 0 because we want it to be a multiple of 3 and 5. So I'm going to put the zeros back. We just need to figure out how can we change it. So when it's this, when we have a multiple of 3 and a multiple of 5, we print that instead of fizz. And if you guys want a hint, I'm happy to give that to you because it's a little bit tricky. All right, so the reason why we're getting this fizz to print out at 15 rather than fizz buzz is this conditional statement was true. And since it was true, it's going to print out fizz and then it's going to move on. So what we want is the occasion that we want to have the most precedence over all the others to appear first. So I'm thinking what we could do here is we could swap these conditions. So we say when I modulo 3 is 0, so when I is a multiple of 3, and when I is a multiple of 5, then do this stuff. Then see out fizz buzz. And then it's going to check for this first. It's going to check, is it a multiple of 3 and is it a multiple of 5? Then it's going to check this. Then it will check, is it a multiple of 5? And if it is, then it will do that stuff. And then finally, it's going to check, is it a multiple of 3? And if it is, we'll see out fizz. So the order that you put these if statements, especially when you have the if and the else if, really matters, because as soon as one is true, it's not even going to check the others. It's going to just see it's true. It's going to execute whatever's in the body, and then it's going to continue on with the rest of the program. So now we are first checking for the condition that has the most precedence. So when it's a multiple of 3 and a multiple of 5, we're going to print fizz buzz. And then when that is true, it's not even going to check for the rest of them. So hopefully, did that make any sense? Why we had to switch those? Yeah, that makes sense.
There's
Okay.
a space on line 9. There's a space on fizz buzz.
Oh, thank you. All right, so that should be our final program. All right, there it is. So we have 1 is 1, 2 is 2, 3 is fizz, so that still works. 4 is still 4, buzz, fizz. Then we get to 15, a multiple of both 3 and 5. We are no longer printing just fizz, we are printing fizz buzz because it checked for this condition first. And there you go. You have your completed fizz buzz program. So if you ever get asked this in a job interview, you guys know what to do. Any questions on this? And I'll have this program along with all the other ones we ever cover available on the SI Canvas page. So awesome. We have completed fizz buzz and we have like 15 or so minutes left. So I guess we'll just finish up for loops today. We'll do the string stuff tomorrow or next week. So I want you guys to help me out with these for loop expressions. So the first one I have listed here is going to loop 7 times. And then I have a few other conditions that I want you guys to think about and think, what condition would you write here? What expression? So if I want to use 12 times, loop 12 times, what condition could I write here?
Int I is equal to 0.
Perfect. What else?
I is greater than 7. I mean, then 12.
Greater than 12.
Less than 12.
Less than 12. There you go. And finally?
I plus plus.
Perfect. That will loop 12 times. So one thing that I want you guys to notice is if you ever have a loop that you want to loop a specific number of times, the general syntax is to start I at 0 and then say I is less than whatever number that you want to loop. and then use I++. This is going to be the one that you will use the most frequently throughout your programming. Will be this loop in particular, where you're starting at 0 and then saying less than the number of times that you want to loop. There are other loops, as you can see here, but this is going to be your most common. So next up, loops 12 times using I minus minus. And James, that looks fantastic. So we say int I is assigned with 0. And if you say I is greater than 12, and then I++, and we'll run these. Actually, I minus minus, you were right. I minus minus. That is combining. Okay, there we go. We'll run these in a second. Okay, so now loops 8,997 times. Well, we said that this is going to be int I is going to start at 0 because that is the standard. And we say I is less than the number of times we want to loop. So 89, 97, and then I++. So it's pretty simple to make something loop a whole bunch of times if you know the syntax. I just wanted to point that out so you guys get that down. Last one, loops 99.09. Any ideas? All right, let's try it out. So I'll say int I equals 0, I is less than 99.09, and I++. So now I'm going to take these and put them in a text editor and see how we did. Okay. So now I will put our answers in here. And I'm going to just see what I is with every iteration of these loops. So I'll just print I in the body real quick. Okay, so we got back no warnings. All right, let's see what we got here. Oh gosh, that's a lot of numbers. Okay, so I can tell you guys that the middle one worked. I'm going to comment that out because we did, in fact, get all the way up to 8,997 if we go through all of these numbers. Oh my gosh. There it is. It's there, I promise. Okay, so that one I'm going to comment out so we don't have to see that. That is causing issues here. Okay, so now I'm going to save that and recompile. Hopefully this will make the output a little bit more manageable. Okay, good. All right, so for the first one, we did loop 7 times. So 0 through 6 is in fact 7 times. All right, so next one, 0 through 11, that is 12 times because we're starting at 0, then working our way up to 11. So that would be 12. All right, this one, what did we get here? We're supposed to loop 12 times using I minus minus. Did that one end up printing? Okay, for some reason that one is not printing out anything. All right, so we'll come back to that one. We'll reassess our conditions. And the last one, we were supposed to loop 99.09 times. We ended up with 99. So I want to talk about this. We can only loop a integer number of times. So it just rounded this to the nearest int and called it 99. So there are ways where you can break loops and make them run like a percentage of a time. But for our current purposes, we cannot loop 99.09 times. It will just end up being 99. All right, so I'm going to comment all of this stuff out so we can just focus on our counting down from 12 and see what is wrong with that. Okay, so here is our I minus minus loop. I'm going to just save and recompile just to verify that we are not getting any output for it. Okay, so we don't have any output for this loop. What do you guys think is the reason?
It's to be I greater than 12.
Yeah, that is definitely a problem because we are starting I at 0 And then we're saying that we are going to loop when I is greater than 12. Well, 0 is in fact less than 12, so that condition would be false and we would never loop. So changing it to I is less than 12 should fix the issue. Apparently it did not. Okay, so we are in an infinite loop right now, which means that this condition was always true. Any ideas?
Oh yeah, we started at 12.
Yes, perfect. When we want to use I minus minus, we start at the higher number and then go down to 0. So the number that you initially assign I to is going to be the first number that will get assigned to I. Let's see. Okay, we have no output again. Let's see. So we're starting I at 12. And then we say when I is less than 0, we're going to output something. Well, 12 is never less than 0. So what do you think we want to do with this condition?
Switch the sign.
Switch the sign. There we go. So now we say we're going to start at 12. And then when 12 is greater than 0, or I is greater than 0, we're going to loop. And then every single time we come back up to the condition, we're going to subtract 1 by 12, and we'll keep going down, down, down until I is no longer greater than 0. Let's see what we get. There it is. We go from 12 down to 1, and this is looping 12 times. Any questions on this guy? It's a little chaotic. I'll clean up this text file later. Hopefully all good. So I'll switch the one in the slides. We said what did we say? Yep, that is correct. All right, so last thing, we'll just finish up for loops. The last thing I want to bring up here is checking how many times the following for loop will iterate. And this could be a test question. Steve might give you a for loop and have certain conditions and ask you how many times is it going to iterate. And remember, iterations are just how many times is it going to loop. So taking a look at the first one, I'll probably just pick a few because this is a lot. The first one, what do we think?
7.
Perfect, 7. And this follows the standard for loop formula where we start I at 0. We say I is less than the number of times we want to loop. And I++, this is always going to be this number right here. All right, what about this one?
6.
Perfect, because we are starting I at 1. So it's going to be 1 less than the previous. Okay, what about this one? It's a little weird.
8.
8. All right, I'll put that one there. And this one, you guys can try. It might be a little confusing what's happening, and I'll talk about it. What do you think? Also 8. All right. 8. Last one, actually second to last one. 12. And the final one, if I tell you that input val is 100. Perfect. All right, so I want to talk about, I think you guys have this one down, and this one down. The middle 3 are a little bit more confusing, but we will go over them. So how you would figure this out is I recommend you should be able to have a scratch piece of paper, and you're going to write down each value of I for each iteration. So we know for the very first iteration, we're going to say that I starts at 12. And then you're going to say, is 12 less than 4? Greater than 4? And it is. So we'll make a tally mark right here. And I'll say values of I. We'll start off with 12. Okay, so now it's going to go through its for loop stuff. It's going to do whatever is in the loop body. Then we're going to come back up, do the I minus minus. So now I is 11. Okay, so now we check, is 11 greater than 4? It is. So we'll have another tally mark here. Then it's going to go through the for loop, do its I minus minus, and now we're at 10. Then we're going to do another iteration. And then we're going to come back up, do I minus minus. Now we're at 9. It's going to do another iteration of the loop because the condition I 9 is greater than 4 is true. Then it's going to come back up, do I minus minus. So we'll end up with 8 now. value of I is 8. And then it's going to do another iteration. And it's going to go down to the for loop, come back up. We'll subtract 1 from I. So we'll do 7, another iteration, come back up. Subtract 1 from 7, we'll end up with 6, another iteration, come back up, we'll end up with 5, another iteration. And then finally, we'll come back up. Is 4 greater than 4? No. So we'll end up with what you guys had, 8. It's a very nice job. And an easier way to figure that out is you could just do 12 minus 4, would give you the 8 value. Okay, so that one's 8. Next one. So we'll do the same thing again. So we're going to start I is going to start off at 4. And we'll say I, 4 is less than 12. So we have an iteration here. That is true. And then we're, what'd you say?
I think that one was 3.
3. Okay, we'll try it. I'll put a comma for 3 here. So we say I is 4. Then we're going to say is 4 less than 12? It's true. And since it's true, we're going to go into the body of the for loop and do whatever stuff it has to do. Then we come back up and check the increment statement. And this increment statement is a little bit different. We've been seeing increments by 1. This one is an increment by 2. So this is just like a normal compound assignment statement that you guys have, where you say variable plus equals a number. This is the same thing as saying I is equal to I plus 2. This is the exact same thing. It's just a shorter way of writing it. So knowing that, we know that I every single time is going to increase by 2. So now we have 6. And is 6 less than 12? It is. We have an iteration. It's going to go into the for loop body. And then we're going to pop back up and we're going to decrease I by 2. So we end up with 8. 8 is still less than 12. So it's going to go into the loop body. And then we're going to come back up to the top. And we have another increase. So we'll say I plus 2 is 10. That is still less than 12. So we'll go into the loop body and we'll come back and check again. And then we say I plus 2 is going to be 12. And now it says is 12 less than 12? And that is going to be false. And since it's false, we don't enter the loop body. So we end up with 4. All clear on that one? It's a little bit more complicated. I don't think you'll see one of these on your test, but I thought I would mention it just in case.
And then isn't that one 0?
Let's check it out. All right, so we're going to start I at 12. Then we say, is 12 greater than 0? Well, yes, 12 is in fact greater than 0. So we are going to have an iteration of this for loop. Then we go into the loop body and do some stuff. And then we come back up and we do the increment statement. And we're at 13. And we're going to check, is 13 greater than 0? Yes. And then we're going to go into the loop body, do some stuff, increment I, and then up with 14. And this is going to go on for eternity. And James, you are absolutely correct. The 5th one is indeed an infinite loop. And I have these for loops. So here are the for loops that we just talked about. And I have them in comments. So we can uncomment them one by one and see what's happening. So the first one, you know what, the first one I think you guys are good on. And the second one, we'll take a look at the 3 that we talked about. So this one, we said that it would loop 8 times. Let's verify that. So now I'm going to compile for, what is the name of this one? For loop. Okay, where is my output? There it is. Okay, so we went 12, 11, 10, 9, 8, 7, 6, 5. And this is 8 iterations, exactly as we said. So that's fantastic. I'm just printing out the value of I here so you can see how I is changing. All right, so that one we got. Next, we have this one. This one I'm pretty sure we said was going to be 4. So let me save. And we got it. It is 4. So we can see the values of I, and this is exactly as we predicted. All right, so this one we said was going to be an infinite loop, And let's check that real quick. And we are absolutely correct. So hopefully that clears up some stuff about for loop expressions. If you do see one of these on your test, I recommend just writing some stuff down, how I is going to increment with every single looping of the for loop. Any questions on these? Great, I'm glad to hear that. Well, it looks like we are at 3:30, but real quick, I want to ask you guys one more time to see if tomorrow you want to talk about string indexing. This is something that Steve mentioned briefly on Monday, where he was saying the indexes of the strings and using the find. We could talk about that tomorrow, or we could do some exam prep. Just want to verify we still want to do practice tests.
I'm down for exam prep.
Okay. Well, we will do exam prep then.
Yeah, me too, honestly.
All right. So tomorrow I will either create a test like this in Canvas or a test like this in Google Forms. And we'll just go through the questions. I'll have you guys tell me which one you think it is. And then we'll talk about why. And then on the following Tuesday, I'll give you guys individual exams that you will take under a time constraint where, where it's a time constraint and you do it on your own. You can ask me questions during it just to get a sense of the questions that you'll see. And these questions here are going to be similar to the ones on your real exam, including the content. So it will have like the content that you've covered thus far. Hopefully that will help a little bit. Any questions for me before you guys head out for today? All right, awesome. Well, I will see you all tomorrow and I will work on creating that exam.
Thank you, Steph.
Thank you, Stephanie.
Bye.
Bye, thank you.